So we're going to go in here. We're going to talk about in-floor heat. And we are from the middle of Minnesota. We've got a long history in doing super performance buildings. The one pictured here has super insulation, a lot of solar capture. You can heat that one with a hair dryer. And it does some other experimental stuff like recycling the gray water back to potable inside one of those greenhouse spaces. It's a lot of fun. We've done a lot of stuff. And with every building, we've wanted to put in-floor heat into it and came up with an easier way to do it. What we're going to cover is a lot of basics around in-floor heat and planning how to get the tubes into the floor and options for heat sources, electric and gas. And then we're going to walk through the setup of our system step by step, along with some maintenance and troubleshooting tips. So why in-floor heat? Sounds like you already know. The warmest part is at the floor. It's actually cooler up at the top of the ceiling. That's unless you have some other heat source that's warming the air. The air can circulate, but it can't make it any hotter up there than it is down there. So you end up with a lower temperature difference across this insulation, which results in some efficiency and a lot of comfort and less dust blowing around. Traditional system components here, we got the boiler, that's where the hot water comes from, and we got the loops in the floor. The loops in the floor all come back to this manifold, then it's pumped around with a pump, but because all that water is contained in pipes, when it warms up, it expands, and so you need to allow for that with an expansion tank, and you need a something to let the air out, and so it's a bubble remover, and you need a pressure relief valve in case the pressure gets too high. You need a fill valve and a drain valve, and zoning to be able to turn on and off different parts of the floor at the right time. It works. It's a lot of complication, and so this is one example of a system with all that functionality made from a couple of pre-made panels to try and make it easier. And it was still a lot of work for this gentleman. He built his house. About a year after he built his house, he found us and went, man, your idea is so much easier. And he came out of retirement to help our sales team. And now his utility room looks like this. Much simpler. Okay, you can use it homes, garages, pole barns, machine sheds, driveways, and sidewalks. So you can use in-floor heat just about anywhere. Okay, and in every case, what you have to do is get those tubes in the floor. So we'll talk about that. First thing, when you're putting the tubes in the floor is you need to think about which zones, which part of the house or space that you're heating do you want to control separately from the other pieces. Most people don't necessarily want their master bathroom at the same temperature as their garage all the time. So they have separate thermostats to control those, and that defines a heating zone. Now each zone, you have to feed loops to. To fill those loops, or to fill it up with loops, you do the layout. Like here we've got a garage zone, a living zone, and whatever that room is, can't tell in that photo. You can do that either with markers on a floor plan, but it's tough to know that you got the lengths right. Or you can use a piece of software, LoopCAD. It's available for free. For a short time for a trial. We offer that as a service, and we will we'll give you that plan. You'll know exactly where to route those tubes to and know that they all come out to about the right length. The length of the tubes can be a maximum of about 300 foot. That's the guideline. And you space it 12 inches in concrete, and between that and 6 inches for just about every other type of floor. Depends on how well that heat spreads between those tubes to give you a nice even heating on your floor surface. Each zone has a thermostat, and this thermostats come in two flavors. You can control the temperature of the slab, or these ones control the air, or based on the air temperature, to try to hold the air temperature even. If you have something else controlling air temperature also, say a forced air system or a mini split or air conditioner, you might want to control based on the slab. So you hold that concrete nice and even temperature, and then you adjust it up and down a little bit for comfort using the air source. The thermostats for air come in a few different levels. One of them is basic. It's just 2 wires, a mechanical switch in there, very inexpensive. Programmable ones will run a schedule. They'll warm it up and down at different times of day or week. That's of limited value with a massive floor because it takes so long to warm it up and it takes so long to cool off. But the Wi-Fi feature means that you can remotely access it, and people with cabins really love that. A lot of people want that so that they can see it from their app and set the temperature, and they can get their cabin to warm up. Additionally, this can be configured to notify you if there's an issue with our system. It can take an electrical input and send you an email, for example, or a notification on the Honeywell app. Okay, here's a quick example to go through. We have a garage space. We have an outdoor patio, front stoop, and we want those to be heated also to prevent ice. And we have a living space, bedroom space. So we'll walk through real quick. We divide that up into the different zones, illustrated here by color. And then we run the loops to each zone, and it ends up looking like this. Notice that the outdoor zones, you have to put a lot more heat into a snow melt system, and so we put that tubing way closer together. Okay, what pipe is it? You're looking for PEX pipe to do this job. PEX B is what we recommend. It's the best for the price. PEX A is more flexible and more money, but PEX B does the job. You want oxygen barrier type. Technically, it's optional for our system. Our system is very oxygen tolerant, but it may be required by code in your area, and it really doesn't cost anything extra to get the oxygen barrier type. And you want a 1/2 inch ID. That's the most common. If you're doing snow melt, sometimes they'll do larger diameter. And you want 300 foot or 1,000 foot, or they come in 300 foot or 1,000 foot rolls. And to make use of that 1,000 foot roll well, first of all, you want an unroller. So it's something that unspools it for you, so you don't end up with just a slinky-like coil as you pull it off the side of a coil. And so that makes it easier to work with. But then you want to plan 4 250-foot loops out of that 1,000 foot, or 3 333 foot, which stretches the 300-foot rule, but almost always works. Okay, concrete floor considerations. Basically, you need insulation under the concrete. Don't do this without insulation. And then to fasten the tube down, the normal way is use these little plastic staples. This is a stapler. He's walking behind. The front guy lays it out. The guy in the back staples it down.
Can you go back to the insulation real quick? Is that a polystyrene or a styrofoam or?
Okay, yeah. This is a traditional pink EPS type foam.
Okay.
And so
is that 1.5 inches or 2 inch?
Most places have a code of 2 inches. an R10.
Right. Okay.
But check this out. This is just about the same price, a little bit more, but usually super close. The one person can do this job. Don't need the staples, except for maybe where it turns around. It makes a loop. Might have to pack a couple points down there. But you can save up to about 70% of your time. At least that's what the pros tell us that are using it. So we sell this heat sheet foam insulation. We found it at a trade show, and we're like, oh man, our customers are going to love that. And they do, and now we're shipping it all over the country. So that makes it way easier to put those tubes down, and it protects the tubing, and just makes everything easy. It's about 2 foot by 4 foot panels, and it's easy for one person to go and snap those together. It's got these little grooves on the edge that snap together. Okay, now you got to manage where all those ends come up from the concrete. So what you want is there's a number of products out there. This is the one we make, and it fits very cleanly behind our box. So that it's all tight and contained and hidden, plus these elbows swivel. They swivel so that you can send those tubes out at whatever direction you want. And that does 10 loops, and you can do if you want just one or two, you can go to the hardware store and get your own elbows, or we sell them packaged up in a bag to add a couple loops where needed. We call it the HUG's Holy Hose Holder because it has a lot of holes on it. All right, Easy Route is another product that we offer. There's others out there on the market. These are the best. The advantage of this one is that you can fit them all under, you can fit up to 18 loops behind our tank to keep them all nice and tight and tidy. And it goes without saying, you want to know which ends, or you want to keep them organized so that you know which loops go to which part of the house. Okay, hydronic heating over a wood floor is another. I mean, not all floors are concrete, so people with wood floors are always asking us what they can do, and so we put it into this presentation. First option, gypcrete over wood. You do a double bottom plate to allow for 1.5 inch fill on the floor. Staple those tubes down, fill it with your gypcrete, and then put your flooring on top of that. Then there are floor panels, warm board, thermal board, eco warm, warm zone, lots of different names for plywood with grooves in it and an aluminum coating to help spread that heat. They are pretty expensive, but they're really easy to work with. You just give the company your floor plan and they'll give you everything that you need. There are other plastic versions of this also. This is on panel. This is Mr. Peck's retro panels. They are available. They're also about the same price. Then you can do it yourself with lower cost materials, a little more labor. Use these aluminum heat spreaders to fasten the tubing down in clean rows and then put strips of plywood between them. There are some good tutorial videos on YouTube for that. There are some not so do-it-yourself versions this is like plywood panels, but without the aluminum coating on it. Okay, this is just a quick summary table. In the order that we recommend, gypcrete is the best price per performance, and then the other panels cost more but perform well, and the aluminum heat spreaders cost less and perform adequately. Now you can also take those aluminum heat spreaders and put them underneath the subfloor. And this is my cousin. We redid his 100-year-old house in St. Paul. with these under his floor, and it worked really well. But it's a lot of overhead work. Be prepared. The materials are very affordable, but it's definitely harder to work overhead than on the floor under you. For an existing concrete floor, we have this foam product. It is sold by a couple different companies. Uponor and Mr. Pex both sell it. And it's got these grooves in it, so it's pretty easy to work with also. There's easy floor grid module that you can string them into. But for an existing concrete floor, the insulation value on this one makes it so much better. Okay, for snow melt, you want a lot more heat, about 100 BTUs per square foot design load. And that means you have to have that tubing a lot closer together. About 6-inch on center is what we typically use for that. And then pave drain is a permeable paver with these holes in them. We've been working with them for a while now. These blocks come with these little holes in them, and when the snow melts, it runs down between the blocks down into the soil. And that works better than having that water run down the driveway and pool, at the bottom of your driveway into an ice lick. Okay, you got loops in the floor, whatever kind of floor you're doing. Now, before you're done with that, you want to make sure you're pressure testing them to make sure those loops are good. So you put we have a particular kit here that daisy chains them all together, and makes it easy. You don't have to put a manifold on to tie them all together. This does that function just with a hose that you push on the end and you squeeze a clamp on it. You definitely want to do that before you pour the concrete, or even as you're pouring the concrete. So if you see that pressure drop, you got some chance of fixing it. Now, what runs through those pipes? You got two choices, antifreeze or water. Use clean water, as clean as possible. We recommend distilled water. And then use antifreeze that's made for heating use. Don't use the RV antifreeze. It's a different blend. It's more biodegradable. Stuff will eat it. The brand we sell the most of is Cryotech, but there's a lot of good brands out there made for heating use. Summary, costs and benefits. Water's cheap, transfers heat better, but it might freeze. Antifreeze is more expensive, will require maintenance. It'll have to be replaced after 5 to 7 years typically. And it doesn't transfer heat quite as well, but boy, that peace of mind is worth it in a lot of cases. But with the most modern houses and the stability of the power grid that we have, most places don't see an outage long enough to actually freeze a house. A house will go several days before it's actually frozen. So there's not many places you have an outage that long. But it's up to it's your house, your building. You got to decide what's right for you. Now we'll talk about the HUG system. Our alternative to this wall of plumbing is this simple little box. We accomplish that same thing as all those pumps and valves with our box of water and a handful of submersible pumps in there. And the pump in the corner here sends that water in the tank up to be heated. Warm water comes back in. Each one of these pumps then sends that water out to one, or in this case, 2 loops in the floor. And there's no valves at all in the whole system. No manifold, no bubble release, no fill valves. It's all very simple. The expansion is handled by the tank. The whole thing is powered low voltage, At 12 volts, the control board turns on and off the pumps according to which thermostats are asking for heat. Pretty simple system. Inside, there's a slight subtlety where the coolest water in the system is what's coming back from the floor. So that comes behind this divider, and that's where this that flows into this pump and up to the heater, comes back hot, and that mixes with everything. And then these pumps send that back out to the floor. The other part of our system that makes it so simple is that we go from the pump up to, we just plug a soft silicone hose over that. And the other end of that hose connects to the loops, the PEX pipe coming up out of the floor. You just push that silicone hose over it, squeeze a clamp, and it's done. One pump can go through a splitter here, and it can feed 2 loops. And then those 2 loops come back through a splitter and back into the tank. Rejoiner, I guess, if it's going that direction. And what that does, we get a special efficiency with less flow resistance. The pumps a lot more, and each loop gets 90% of the same flow that a 1-loop pump would get. So we run those pumps at medium to make up that little difference, and it increases our capacity. So one box can handle 10 pumps, and that can cover over 5,000 square feet. You can use it on the floor that it's sitting on. You can use it on a floor above. You can do both, up and down. And you can actually have it go up 2 floors from the one it's sitting on. What we don't recommend is radiators. It's an extra level of complication. If you absolutely need to, talk to us about it. But it's an in-floor heat system primarily. Now, the way you specify a system, you start with a base tank, and you add the pumps for your needs, for your heat sources, for your loops in the floor. We can do 1-loop pumps, 2-loop pump kits, and then you choose your heat source. A low-pressure boiler has the easiest plumbing. We have an assortment of them in gas, electric. We can do a combi boiler, which also does your domestic hot water for showers and sinks and stuff. And we'll talk about selecting those next. What's going to warm up your house? How big a heater you need will depend on how big your house is, how much wall surface, where is your house located, how much insulation does it have, how many windows, because windows are lower insulation. They're about R3 on average. And a typical new home is is safely under 25 BTUs per square foot. So that's, if I have no other information about a home, that's where I'm going to start. There are plenty of more sophisticated ways to calculate all the different surfaces and heat loss in your home. A manual J is what it's typically called. There's websites like CoolCalc and ResCheck that'll help do that, and we can do that for a fee also. Now, which fuel? Now that we know how much heat your house will need, now which fuel are we going to use to get there? Do you want a combi boiler with that? And do you need antifreeze? All of those will determine what's the best option for you. First, the cost of fuel. Electricity is most expensive, then propane. If you can get a dual fuel electric rate, you're better off. Heat pumps are very efficient. Natural gas is just really low cost. It's a good deal. And if you can run a heat pump on dual fuel, more power to you. Actually be less power, come to think of it. It would burn less power. All right. And the costs change based on where you are and over time. So the most typical options, most typical heaters are electric or gas, which would be propane or natural gas. These are our two favorite units. They're made by state. They're rated for space heating usage. There's electric in 12 and 18 kW and a variety of other sizes. And for the tankless water heaters, the gas tankless water heaters, the 120,000 BTU package is very economical and efficient, but it does not run well with antifreeze. To run, okay, here's the trade-offs again. Electricity, higher cost to operate, lower cost to buy and install. It's the opposite for a gas water heater. If you need antifreeze, you're talking a more official boiler than a boiler is made for space heating usage specifically, unlike the on-demand water heaters that are just rated for space heating also. We offer a line of boilers that handle antifreeze fine in electric or in gas and propane. These ones are low pressure. They work well with our system. And for the bigger boilers, sometimes you need a bigger pump. So these low pressure boilers and combi boilers work like this. Blue hose goes straight into them. Blue hose comes straight back. For a gas, or for boilers that have a pressure switch in them, it requires all this extra plumbing. It's to maintain a pressure loop. It's doable. We even made a model with the heat exchanger that sits right inside the tank. It makes it easy, but it requires extra fittings to be able to make it work, to maintain that pressure loop. So we put together a kit for Navi and Renai for that. They're the most popular boilers in that line. We can also do Rude and Lennox or something like that too. For wood boilers, you put that heat exchanger on the wall, and you can offer an electric backup. You can go dual fuel if your electric company offers a dual package, a dual fuel rate, which means that they can turn off your electric, but they give you a better price. Then it makes sense. Usually there's a 3 to 5 year payback to add whatever you need to add the other one. If you were going to go straight propane, you can save money by using the off-peak electric a lot more. And if you were going electric, you can add a propane boiler so that you can go off-peak and save money. To do that, to run both of those, we developed this little add-on that allows it to switch between boilers when the utility asks to turn off the electric. You can do up to 3 heat sources with our system. And we've got cool web sources, videos, manuals, quick start guides, spec sheets. And a report just in case an inspector has questions. We have a report on using our system and how it meets a fundamental code. Some people wonder about the suitability of the hose and the pumps. The hoses are made to last 20 years in an engine with hot antifreeze going through it and vibration and dust and oils and such around. Your utility room's not going to be a challenge, and the pumps will push as hard as any other pump on the market, but at a lower volume, which is ideal for the 1 or 2 loops that we're asking it to move water for. All right, follow me still? Let's
still
get
with
into,
you.
Good. Let's get into what it takes to put this thing in. So there's we're going to prepare for the install. We're going to hook up the floor loops, hook up the boiler. We're going to wire the thermostats. We're going to fill up the tank, and then we're going to fill up all the loops, all the lines in the floor, get all the air out of them, and we're going to do a look at the configure a few settings and then make sure everything works. First of all, you want the loops in the floor, you want the boiler on the wall, and you want an outlet nearby, antifreeze if needed, and a few basic tools. You're going to need a tiny screwdriver, not pictured here, and pliers, tubing cutter, and wire cutter. Step one, take it out of the packaging and take everything out from inside the tank, all the packaging material that held everything in place. Then make sure that these pumps, the intake nozzle on them has there's a little grooves that those sit in. Just make sure that they're in there facing the right direction and slide it into place right near where the PEX comes up out of the floor. There's a front plastic cover. You slide that up to get at the control board. There's a tank lid here. Pop the latches, open that up, and a power supply on the side. There's a top cover that's just held on magnetically. You can just pop that loose and get at all the loops on the back side of it. That looks like this. This is underneath the cover. This hose goes to the heat source on the wall, to the boiler or heater. This comes back from the boiler. Each one of these connects to the loops in the floor. Inside the tank, these are the pumps that connect to the loops in the floor. This is your heat source pump, and it sticks through a little hole on the back wall there into that back section. This is the water level sensor, and that's just a visual gauge to show you where you are with your water level. We're going to connect the optional overflow drain here. If you have lines that are overhead, it's probably a good idea to put this in, but it's still strictly optional. It's just a half-inch hose. You push on that fitting and run it to a floor drain or like a condensate pump. All right, now we will connect the PEX pipes, and I'm going to skip straight to the video we have. All right. We'll do this thing where we watch the video and then talk about it. So you get a little bit of repetition here from a different couple of ways. So to connect those, you can cut all the tubes to the right length, push the hose over it, squeeze the clamp. Now to undo the clamp, one thing the video doesn't show is you grab one half of it and you kind of slide those teeth sideways to each other and it'll pop loose, and you can remove the hose and adjust it if you need to, or replace the clamp. With the water heater, you put the fittings on and you push the hose over it, you squeeze the clamp. Sometimes it's necessary to support that hose so that maintain a good curve up there. Now we'll talk about wiring. There's a little port in the middle to run your thermostat wires in. Wires can run, down the wall and then cut over and up into this unit. Older systems will have this green board. As of about the first of the year, we have moved to a white colored board that's a little more user-friendly, a few new nice features. The wiring connectors for that look like this. Thermostats, run a thermostat to each one of these if needed, if you have that many thermostats. The W, R, and C connect to those terminals on the thermostat. Simple thermostats only have 2 wires. Other thermostats will have more. If you have a smart thermostat that requires 24 volts, we'll run that from a external power supply into this connector. If you have a boiler that requires an electrical contact to start it, we have a relay on board for that. And we have an alarm output that can be wired to a smart thermostat, certain smart thermostats, to let you know that there's a problem. We will walk through that in video here. Okay, quick review. Strip thermostat wires, do the outer shield, and then just about a 1/4 inch at the end. This is example 2-wire thermostat, 3-wire thermostat. Come on, there we go. This is how the two-wire thermostat connects and diagrams, the W and R terminals on that, on the base of that. For 24-volt thermostat, we add the power supply. The one side of the AC and ground go into one side of that 24-volt connector. The other side goes to the other side of the connector. At this point, we have to pull this jumper. Our board runs on 12 volts. The 24-volt power supply can backfeed into it unless we pull this jumper, which isolates it. The board won't break if you forget that, but it may not function right either. Now we've got 24 volts for the smart thermostat. We can connect the W, R, and C terminals of that base of that thermostat, W, R, and C. And additionally, we run 24 volts into this C pin here for the alarm output. We can run that alarm signal into the A pin on that thermostat, and it can be configured then to email you if there's a problem. If you have a boiler that requires electrical contacts to turn on, we have that here. The alarm output, when it goes into alarm mode, it makes a sound, and that can be set using this jumper here. We can set the audio to high, low, and off. It usually only goes into alarm when the water level goes low. It'll also do it if a pump fuse blows, but we've never had one happen in the field. There's a zone expander option. I just want to show that here, but I'm not going to go into all the instructions for installing it. If you need more than 4 zones, this can expand it up to 8. And it just plugs on, and then you with a few, each thermostat has its own connector. Okay, we have wired it. Now we've plumbed it and wired it. Time to fill it. So if you have your glycol, your antifreeze available, pre-mix it outside the tank so that you can go into all the floor loops pre-blended. We're going to need, for every 300-foot loop of PEX, you're going to need 3 gallons of fluid. So if you have a 2,100 square foot project, you're going to need 21 gallons of that for that in a concrete floor. Going to be 7 loops at 3 gallons each, and the tank itself holds about 8 gallons. So you're going to need 29 gallons. And we have a video for that. All right, we'll step through that real quick and review. We're going to open the control board. We're going to unplug the thermostat connectors so that we don't have a whole bunch of thermostats trying to turn on too many pumps at once. We want to control the pumps and turn them on one at a time. Then you turn on the power supply, and we are ready to start. We're going to purge the air out of the loops one pump at a time. You take one of these jumpers, put it on these pins labeled purge in the section for each tank, one at a time. And that'll push the water and run the pump at maximum speed and flush all the air out of those lines. And when it stops gurgling, then you're done with that pump. And you just go purge each pump one at a time. At this point now, it's time to fill the boiler loop if you have one of these ProLine heat exchanger pressure loops. Odds are, if you do that, if you're using one of those boilers, you've used them before and you know how to pressurize it. So I'm not going to go into too much difference or too much detail here. All right, the system settings now. We've plumbed, we've wired, we've filled the system up. Now let's make sure that everything is set right. All right, quick review. First thing we got to do is tell each pump which thermostat controls it. So when that thermostat turns on, the right pumps turn on that feeds that part of the floor. We do that with a simple jumper. You just set the jumper on to the corresponding zone number that thermostat is hooked up to. Next, we're going to assign the pump speeds. For one loop pump, low is plenty adequate. For a two loop pump, you want to set that at medium. Max is what you want for heat sources. Temperature settings. The tank has its own temperature limit. So you can put in high temperature water, but it'll only let the tank get as warm as you have set here. So you move that jumper to set it based on what highest temperature you want to go out to your floor. 110 to 125 is typical for concrete. 145 or higher may be necessary if you've got the type of floor, like if you're feeding underneath a wooden floor. You need it hotter to be able to get that heat to flow through the wood and up into your room. Zone 4, there's a low priority option for that. So think of it like a house, it's a garage. The house is on zones 1, 2, and 3, and zone 4 is on the garage. When that jumper is in place, it will not send heat to the garage as long as the house needs heat. So if zone 1, 2, or 3 is on, zone 4 will not run. All right. Now all the settings are done. It's time to do a few final checks. Now is a good time. Make sure that the water level is up at the full mark. And you can add a calendar reminder to check it every 3 to 6 months. You can reinstall and latch the cover. The water may be hot already at this time, so careful with that. And we're going to turn the thermostat on now and make sure that the correct thermostat light turns on and that the correct pumps come on for it, including the heat source pump. Make sure that the heat source is flowing up, or you can feel it going through the boiler, and that the boiler is returning warmed up water. You can just touch the hoses and feel the difference between the in and the out there, and it should be notable. And one more quick review. Okay, we have covered installation. Now it's time to go on to just a little bit of troubleshooting info. First, what do all the lights mean? On this version of the board, the lights shine from the back and reflect on the aluminum behind it. The power light is pretty self-explanatory. I'm not going to spend too long on that. It's green when it's got power. Each pump has a light on it that when it's off will be it'll be totally off, or a very light green if there's no power going to it. It gets brighter and brighter the more power the pump draws. So if the brighter the green, the more the pump is pushing until maximum. At maximum, it's yellow. Yellow is not a problem. It works just fine, but we're at its upper limit. If a fuse blows, it'll be red. Low water is another red light. That's a problem. That turns off all the pumps. You want to definitely know about that, and it may go into alarm mode and make noise. Max tank temperature, as we said, we can set the max temperature that we allow the tank to get to, and when it approaches that temperature, it will turn on this light. It's an aquamarine color. It's like chill. We're happy. We're content with this amount of heat, and it turns off the heat source to the boiler, or it turns off the pump to the boiler. Now, each thermostat has its own blue light. So when the thermostat's calling, that light is on. Zone 4, if it is in low priority mode and being overridden, instead of being blue, it will appear a yellowy color. Like I mentioned, we've never had a fuse blow in the field, but in the case that it never does, this is where you check it. These little green boxes, you just pop them off and you can see it in there. And the pumps come, the system comes with an extra fuse, and the fuses are available locally if ever needed. Now we're going to troubleshoot. If you come in and the thing has no power, first of all, check the switch on the power supply. If the switch is on, then is the power supply light, oops, let me come over here. There, is that light lit? If that light is on, then the power supply has power, but the board doesn't. It could be this connector here. You want to unplug that. It could be a wiring problem on the back. You can test that. And at any point along here, give us a call. And our tech support is happy to walk you through any of these troubleshooting steps. If your power supply is turned on, but the light is not lit, then you check the cord at the back of the power supply and make sure it's plugged into the wall, or plugged into the back of the power supply and the wall. If it's all plugged in fine, then it could be your breaker. All right, we walk in, the house is cold. First thing you do is go look at the thing, check the power. Is the power light on? Is the thermostat or is the power supply switch on? Just like we talked about. Next, are the blue lights for the thermostats calling? Do the thermostats know it's cold? Are they asking for heat? If the blue light's on, that answers yes. If the blue light is not on, check your thermostats. Um, make sure that the power supply for the thermostats is still plugged in and working. Now we're going to check if the thermostats are calling, make sure that the pump lights are running, or the proper pumps lit and green. Then is the pump to the boiler working? If the pump to the boiler is flowing, check the flow through the boiler. Like I said before, you can touch and make sure that that water is coming back warmer than where you sent it. And if it is coming back warmed, but the house is still cold, maybe there is not enough, maybe the boiler needs to be turned up so it puts hotter water into our tank. Hotter water is more heat to go out to your floors. Okay, here are 2 example installs of a gas water heater system. We've got our line, cool water going in, hot water coming out. And that is fed with a gas line and fresh air coming in, exhaust air going out. And when you cool down the exhaust air like it does in here, you get condensation coming out of it. And this is the condensate drain. All right, that is it. We made it, we survived, and now we're available for questions.